Welcome to this technology demonstration. We will explore the workflow between Inventor and Generative Design within Fusion 360. Both products are part of the Autodesk Design and Manufacturing collection. In this example, the design team has been tasked to find a better and more competitive solution than the heavy-gauge steel bracket that connects the spot welder to the robot arm. Because the team already are proficient in Inventor, all the modeling will be done within that application. Generative Design is a design exploration tool utilizing parallel compute in the cloud to provide design options most could not have thought of. Unlike topology optimization, there is no need to include proprietary Cad data. The team is simply going to create a standard Inventor file and locate it in the Fusion team folder via Desktop Connector. This file will contain two objects: preserve regions, what in this case will be the areas the brackets mount to the welder and the robot arm, and obstacle regions. This is the defined area where we don't allow the material to be built by Generative Design. This includes space for screws, counterbores, and any tooling that needs access. The modeling within Inventor is done with three simple commands: sketch, project, and extrude. Navigating Desktop Connector via Windows Explorer, we can see the Inventor file located in Fusion Team. When opening Fusion 360, we see the same folder structure in the data panel, and with any Cad available in both Inventor and Fusion 360, we can bridge this workflow seamlessly. AnyCAD is a powerful tool in Cad Data Translation. When double-clicking on the Inventor part file inside of Fusion 360, AnyCAD opens the file without any risk of loss of data. Instead of converting the data from one platform to another, AnyCAD creates a portal for you to look at the original Cad data. What that means is that the file we see on the screen within Fusion 360 is a direct view to the Inventor file. Any changes made to the original file will reflect from one software to another. But before we see that in action, let's rotate the model to a better manufacturable position. See, another benefit versus topology optimization is Generative Design will take different manufacturing approaches into consideration. This assures that the design team are getting more options and can make better decisions as what can be manufactured with the capabilities they have on hand. With the preserve and obstacle regions rotated to align with the X, Y, and Z axis for additive and standard 3-axis milling, let's take AnyCAD for a spin. The design team realizes that they are missing obstacle regions on the attachment on the spot welder. Again, since Inventor is their preferred design tool, this task can be done in minutes. No need to waste time and frustration learning another Cad tool. Hitting the save icon within Inventor will trigger a notification of a new update within Fusion 360. With one press of a button, the changes from one software are pushed to another. And you guessed it, these types of updates can go from Inventor to Fusion 360 and from Fusion 360 to Inventor. With the new update in place, we can look at the Generative Design workflow. We will specify the preserve regions and the obstacle regions. Apply a constraint to where the bracket will be mounted to the robot arm, and then apply the loads to the portion where the spot welder is mounted. The spot welder, now without the heavy gauge bracket, weighs about 50 kilos. And though there is no physical load on the other directions, we will apply a reaction load as the spot welder can rotate 360 degrees. Next, the team will select the manufacturing process. One unrestricted, that could be done with a wax to sand casting process. Second, an additive, this could be metal powder printing. Here we can control print thickness and overhang angle. And lastly, a standard 3-axis milling process. Not only will Generative Design let you explore many design options, it will also let you explore up to 10 different materials per study. Would it be possible not only to lightweighting the heavy steel bracket? Could the part be done in a lighter and cheaper material like 6061 aluminum? Utilizing parallel compute on the cloud, we will have results starting to appear in minutes, not hours. And using filtering tools, you can quickly narrow down the selection and start investigating what designs can be utilized. The unrestricted method creates an almost futuristic model. At Autodesk, we have had great success in producing this with a wax-printed core that then will be sandcasted in, for example, aluminum. Looking at the additive version in the Z print direction, there is potential, but with the flexibility to scroll the iteration bar at the bottom, the team can guide an output closer to what they're looking for. Lastly, the subtractive version. Generative Design created this on the instruction of 3 setups on a standard 3-axis mill, machining from the top and 2 additional setups with the parts on the side. In this case, the design team wants to validate each manufacturing process within their Inventor Design workspace so they can present the results to management. But before getting to that point, they decide to utilize that Generative Design creates edible solid models. Now the team can change the Generative Design output, add their knowledge and experience to make the design their own. Just as before, where AnyCAD was used to bridge the workflow from Inventor to Fusion 360, the design team can again utilize the security of AnyCAD and eliminate time wasting. Within the comfort of Inventor, they will navigate to the Fusion team folder and using the joint command and AnyCAD to attach each version of the bracket to the robot arm, letting the team explore and validating the best design for them to move forward. In this short video, you saw the design team utilize the Autodesk Design and Manufacturing Collection, explore more design options with a better fit to their manufacturing process, spending less time getting a more competitive solution.